This lecture sections, here we will see the plots of angular wave functions today. So you know already angular wave function is written as the psi of theta phi. Already we have seen in the previous lectures. So it depends on the quantum numbers of L and M and independent of principal quantum number, that is n, for given orbital. So in case of S, what happens? You can see this is the graph, spherical graph. This is actually mathematical calculation is there. So we can see here S orbital looks like this one. This is the theta orbital. This is the angular momentum. So L is there. So this theta. So this becomes like this graphs. In case of PZ orbitals, so this becomes like this one. So two sphericals are there. This is the theta. So theta can be vary. So here one more diagram is there in which it is very clear how we can calculate the theta. We can calculate theta with the help of mathematics. So this is the PZ orbital. So if you take the higher orbital, like this is the, if suppose this is second orbital, if you take the third orbital, so this graph becomes not third orbital, this is the sine, this is called sine, this is sine, this is the mod of sine square. In the mod of sine square, the orbitals becomes elongated. So you can see this elongation of the p orbital. So sine has a no meaning. Why no meaning? Because it depends on positive and negative functions, but positive sine square is always meaning. So it will be your elongated graphs. You can calculate the graph by using the mathematics. So it depends on the theta. So you can see these points are there. If theta difference, theta 0, theta 90, theta 180. So from Schrodinger wave equations, we calculate these points and we can draw that with the help of mathematics, these points like this. So after drawing these points, we will understand why the shape of the p orbital is quite dumbbell shapes. So this is the polar plot of the angular wave function. Now sine. So sine already we know very well. So it is the angular part of the angular part and independent of angle and has a constant value. It is circular, spherical. So as per the Schrodinger wave equation, we have drawn this diagram. This comes like a spherical. For P, we will having a two tangent sphere that is oriented in x, y and z respectively. If you take D and F, so D have a 4 lobes, while F having a 6 lobes respectively. So this is actually we are getting from the, these graphs we are getting from the Schrodinger wave equation. This is not the graph actually electrons have. Electrons is we are calculating on the basis of the mathematics. Angular probability density sine square. So sine actually has no meaning. So you have to take sine square. So in sine square you can see here graph is again same here. So sine square means different orbitals change in different ways. How? See here for S orbital, there is no change in shape. Shape will not be changed, only there will be increase in shape, means the shape will be concentric. So functions everywhere is same, so another space is obtained. So for p orbital you can see here, if you see the p orbital, so they have 2p graph like this one, but if you take 3p orbital, there will be overlapping. So you can see here this is a one orbital, this is another orbital, and between one is the spherical node, this is the planar nodes. So p orbital has two nodes. Already we can calculate here n minus l minus 1. If you take l equal to 1, 3 equal to 1, they equal 1. There will be one radial nodes, this is the planar nodes is there, and there is one spherical nodes is there. There will be two nodes. In the case of D, you can see here this is a 3D. So 3D we have one graph is there, but if you take 4D we have two. One is this one small one is big one. So in between one node is there, and this become more elongated. So the shape of this is elongated if you take the higher orbitals. So this is actually what happens in the angular probability densities. So these are the graphs, keep in mind. Welcome to this lectures. So आज के इस lectures में we will study about shapes of atomic orbitals. So to interpret and visualize the atomic orbitals in an atom, the diagram is based on psi square is constructed. So as we have seen in previous that to visualize the atomic orbitals, we have drawn that diagram, and that diagram is totally, it is based on mathematical calculations, that is Schrodinger mathematical equations. So this we can represent in two ways. One is the charge cloud diagrams and second is the boundary surface diagram, charge cloud. So what is actually charge cloud? So we will see these two one by one. What is the charge cloud diagram? Charge cloud diagram is actually this is the collection of dots collection of dots or electron density. So this is since it is a dots, these are the dot. We draw this orbital in the form of dots. So all these are actually dots. So this is x, y, and z plane. This is x, this is y, z plane. So all these are electrons are in presence of dots. So this is the charge densities for 1s. So if you see here 2s, there is two sphere. So this is the one dots and this is the another dots. So here most of the electrons are there. We can see here space over here in between the two dots. This space is called as a nodal surface. We already know what is the meaning of nodal surface, and this dots is actually looks like a spherical symmetry. So this is a spherical node is there. This you can see totally spherical node is there. And how to calculate this spherical node? So we have one formula, that is n minus 1. Like if you take 2s, the 1 spherical node, 3s, 2 spherical node. In this way we can calculate this spherical node. For p orbitals, we can draw this charge cloud diagram. So this is the dots. So we can see here one plane. So its x-axis, nodal plane is yz. Yz means along this yz there is no electron dots. Similarly, in py we have nodal plane xz. Here no electron dots, but here will be electron dots. In 2pz, nodal plane is there along the xz. So there is no electron dots is present on the xyz plane. And this shape is actually called as dumbbell shaped. And again we can calculate the number of nodes in the p subset, that is n minus 2. This means if you take 2p, 0, no nodes, 3p, 1 nodes, 4p, 2 nodes, we can easily calculate. p orbitals are directional, s orbitals not a directional. S orbital is not directional because here it is going in any direction. So this is called as a non-directional. Why? P is having a directly axis. We can see x-axis, y-axis, z-axis. So this is called as a directional. So all these p orbitals have equal energy. We can see suppose there are 3 orbitals, energy wise all are equal to each other. 2px is equal to 3px, 2py equal to 2pz. 3px, 3p all will be equal to like this. But energy of 3p will be greater than 2p. You have to keep this in mind. Now we'll see plots of the angular wave functions. So here we'll see the D diagram. So here in this D diagram we can see here 3dyz, 3dxz, and 3dx square minus y square, 3dxy. And this is the baby Sudar model. So we can see the nodal cones here. Here again we have nodal planes in 3dyz. Yz is the nodal plane, means here there is no electron dots. Similarly here we have no electron dots. Here xz we have no, this xz plane we have no electron dots. And here dz, here there is no electron dots. So in all these we have two nodal planes. Okay, one is x y plane, one is z plane, one is x plane. So everywhere there will be two nodal plane, 2 2 2 2. And in here we don't have nodal plane. Instead of nodal plane we have a nodal cone. So there are two nodal cones are there, but two nodal planes, two nodes will be there. So keep in mind these questions are often been asked. It is 4 lobes, and again not all have same energy in absence of magnetic field. So here p orbital, as we have previously seen, they have the same energy, but say in the D subset also they have the same energy, but it will be in absence of magnetic field. But if you put any magnetic field, then what happens, this D orbital will be split into two different type of orbitals. One is a dxz, dyz, txy. There will be 3 plates. This is called as a triple generator, T2G. And the two other orbitals, dx square minus x square and dz square, this is called a doubly generator. This will be split into other types. So both will be having different type of energy. So this depends on the types of unpaired electrons. So this we will study later on, but this we have to keep in mind that degeneracy is maintained in absence of magnetic field. If you put magnetic field, they will be triple generated or they will be doubly generated, known as EG or T2G. So there will be two energy, T2G energy and EG energy. There is a second way of represent the boundary surface diagram, that is called the surface of constant probability, that includes the region of maximum probability. So here we will draw the diagram properly, that is not like a dot like a structure. So here we draw the surface of the diagram in form of boundaries. How? Let us see this one. This is the diagram of boundary surface diagram. We can see the boundary of s orbital, px orbital, py orbital, pz orbital, and here all the orbitals taking together. So this is the diagram of all the orbitals. So we can see over here. So again I am showing this diagram again. So this is the diagram of actually boundary surface diagram along with the nodal plane. So you can see the nodal plane of dxy, dxz, dyz, dx square minus y square. Here you can compare yourself. So, and dz square we have conical surface in this form. Okay, so here it is very clear to you that which are the nodal planes present in the d orbitals, and this is the boundary surface diagram. So from this it is easy to answer any questions.